before we do logarithm function, I would like to review two important facts. One is that 2 cubed divided by 2 to the 5th equals 2 cubed is 2 times 2 times 2 times 2 3 times. 2 to the 5th is 2 times 2 times 2 times 2 times 2 5 times. Okay, remember 2 times 2 times 2, you can always put times 1 there, okay, because 1 times 8 is still 8. When you do the consolidation upstairs and downstairs, so you have 1 left, okay. Downstairs you have 2 times 2, which is 2 squared. Now, you also know 2 cubed divided by 2 to the 5th. Division, we should use the subtraction of the exponents. That 3 minus 5 gives you -2 for the exponent. So this tells us 2 to the -2 equals is 1 over 2 to the exponent 2 without negative sign. We know this is 1/4, okay, which is a positive number. So here I want to make sure 2 to the negative number is actually there is a numerator 1 upstairs. Downstairs is still the base 2 to the same exponent but without negative sign. That's one thing, which is a positive number. Can never be negative, this number. Another fact is that, when 2 cubed divided by 2 cubed, upstairs is 3 twos, downstairs is 3 twos. And 1 can be used 2 times those 2 to 2, 1 times 2 to 2. So again, when you cancel those 3 twos upstairs and downstairs respectively, you have 1 left. You also know upstairs is 8, downstairs is 8. So 8 divided by 8 is 1. On the other hand, by the algorithm of subtraction, exponent minus exponent, that's 3 minus 3. So you have a 2 to the 0. 3 minus 3 is 0. So 2 to the 0 is 1. Actually, 3 to the 0 do the same thing. Is also 1. Okay? 100 to the 0 is also 1. Okay? So that's the thing we want to be clear. A positive number to the 0 is 1. A positive number to the negative exponent equals numerator upstairs is 1, downstairs is the same base with the same exponent, but which is positive. Remember those two facts. We'll use this. Now, right here, that's the logarithm function we need to talk about. Before we do the logarithm function, let's review this one. We know y equals radical x. This function, if you input 0 here, so radical 0 is 0. If you input 1 here, radical 1 is 1. If you put 4 here, radical 4 is 2. If you input 9 here, radical 9 is 3. Okay. Now, if this is f of x, then 0 goes to 0, 1 goes to 1, 4 goes to 2, 9 goes to 3. Okay, then we also know that for the inverse function, you want to find if 0 goes to 0, 1 goes to 1, 2 goes to 4, 3 goes to 9. Yeah, so far we know that that's the y equals x squared, because you input any number 0, 1, 2, 3 here, 0, 1, 2, 3 here, you square it. Okay, you have a 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So this one, when x is greater than or equal to 0, then this one is the inverse of this one. Or this one is the inverse of this one. Okay, remember here, radical x equals x to the 1/2. And then you can see mathematicians use square to square the numbers, goes to the left. And then they use x to the 1/2 as a square root. Okay, this is the thing we want to be aware about. Okay, then you also know that if you recall the previous lecture, we have a y equals radical x as this one as a curve, and then for y equals x squared we have this curve, and then two graphs are symmetric with respect to this line, which is y equals x. Now probably we are ready to do the logarithm function. You know, logarithm function is actually the inverse function of exponential function. It's like here, y equals x squared is the inverse of y equals x to the 1/2, or y equals x to the 1/2 is the inverse function of y equals x squared. Okay, so you can say one is the inverse of another. All right, and here we want to be sure, keep in our mind, logarithm function is the inverse of exponential, and exponential is the inverse of our logarithm. Look, here is an exponential function. Now the variable is an exponent. Now the exponent changes. Here previously, you see, only the exponents are not changed. Okay, so here is 1/2 fixed, here is 2 fixed. Okay, but here in this case, exponent is changing, so we say that's exponential function. Okay, we know x can be positive, negative, and 0. Remember we reviewed at the beginning, if you input -2 here, so 2 to the -2, again, remember 2 to the -2 is 1/2 squared, which is 1/4. That's why we reviewed. So here, feel confident. X equals -2, 2 to the -2 is 1/4. X equals -1, 2 to the -1. To delete negative sign, you need to have a 1 numerator upstairs. Okay? And then downstairs, you still have the base 2 and the exponent 1, but it's just positive. Okay? And we know 2 to the first is still 2, so that's 1/2. Okay, if you input 0 here, 2 to the 0, remember that's what we reviewed. Okay, any number to the 0 you get 1. 3 to the 0 is 1, 100 to the 0 is 1. The reason is right here. So any number to the 0 is 1. Here we have a 2 to the 0. That's 1. Actually 3 to the 0 is also 1. Okay. Now, if x is 1, you input here. You input here 2 to the 1 is still 2. Okay. And then you input 2 here. 2 squared is 4. If you put 3 here, 2 to the third is 8. It's because 2 times 2 times 2, you have 8. Okay? Which is not 2 times 3, you got 6. That's a popular mistake. Okay, 2 cubed is 8. Because that's 2 times 2 times 2. 2 times 2 is 4, times another 2, you got 8. That's important. Okay, so we have a x, then we have a y. Put in the picture, -2, -1, 0, 1, 2, 3 is here. Then you have a corresponding value right here. 1/4 here, 1/2, 1, 2, 4, and 8. Now, what's the inverse?